Welcome to our course, Doing Math in Python. In this part of our course, we are going to have defining symbols and symbolic operations. So this lesson is very much basic and it's actually introductory to more in-depth and more technical and higher lessons in algebra and calculus. So what is a symbol? Symbol is a term that is a general name for XS, YS, AS, BS that we use in equations and in algebraic expressions. So maybe you would want to ask me right now, can we also use only one letter? Yes, actually we can. So we can use A, we can use B, we can use C, we can use D, and so on and so forth to mean a symbol that stands for something else. So when we say something else, it must be a value. And the value can be negative, it can be positive, it can be zero. But of course, there would be some problems if we're going to use symbols in Python. Of course, in algebra, or we can just directly compute for something else that stands for something else, of course. But in Python, it's working a different way. Say, for example, we have here x, which is a variable, is equal to 1. So let's execute this so that we will know the answer. So when we have this x plus 2, then the result would be 4. But basically, what happens in algebra, it must be like this. X plus x, they have the same coefficient, so that becomes 2x. And we can never add 2 to x plus x because x, or I mean 2, does not have any literal coefficient. So the result is supposed to be 2x plus 2, but it cannot tell Python that the result is 2x plus 2. So we have here a problem in combining, in adding, in having mathematical operations with respect to a number and a symbol. In Python, SymPy is very helpful for us to write programs to express mathematical expressions in terms of such symbols. What do we do in this case? So here, from SymPy, we import symbol, and x here is equal to symbol. Then we enclose a certain symbol in a quotation mark. Then of course we have here a parenthesis. Okay, so that means we set a certain letter to a symbol and we assign this value or symbol to a certain symbol, but in this case we have here x. All right, now with the use of this, we can now represent this one, the x in this case, to be the symbol, and we can have a result 2x plus 2. So let's go to this one. Now we have already have the symbol and we have assigned this particular symbol to x. We have here x plus 1. So let's see what the result would be. Okay, it's now computing. Now, so see, we have now the answer as expected, mathematically, algebraically, 2x plus 1. So of course, we can also assign any letters to a certain symbol. So for example, we have A is equal to symbol T. That means A is equal to T. So we have A plus A plus A plus 1. So what would be the result? Now we have 3T plus 1. So we have A. So 1A plus 1A plus 1A, that becomes 3T because A here is equal to T, then plus 1. So in some cases too, actually in most cases, we use multiple symbols. To define multiple symbols, we can actually have two options. We can create separate symbol objects, or we can use the symbol function. So for example, we have x is equal to symbol x, y equals to symbol y, z equals to symbol z. So let's execute this one. So it means in this case, we are creating separate symbols, symbol objects for x, y, and z using different operations or set of functions. So we can also do that all at once. How do we do that? We have from SymPy import symbols. So x comma y z equals to symbols. So in this case, we use symbols with s here. It's because we are using 3 symbols. So x, y, z. Now let's execute this one. Okay, that is already executed. Now we can carry out the basic mathematical operations on them. For example, we have a is equal to x times y plus x times y plus y times z. As you could see here, we have a lot of things going on in here. So let's see what would be the result. And I'd like you to think what the result would be. And let's see if we have the same outcome. So let's execute this one. So we have 2xy plus yz. So why 2xy? It's because we have here 2 and 2x's here. So we have 2y here. So we have xy plus xy. Why do we have xy? Because x times y, that becomes xy. X times y, that becomes xy. So we add that, then we have 2xy. Then we also have yz because we have y times yz. We can never add yz to xy because they have different literal coefficients. So that's why we have 2xy plus yz. So that's how we do it. What about this one? So what would be the result of this? Can you picture out that one in your mind? So let's execute this. Now we have 2x squared. Why is it 2x squared? So basically we have first x plus x, okay? So that becomes 2x, and then we times x and then x times x. So we multiply x twice. That's why we have x squared in this case. So what about this one? Now this is going to be something different and the result might puzzle you. So let's execute this so we would know. Okay, so as expected, we have x plus 2 times x plus 3. So why is this different from this one? So as you could see, we have here two quantities of polynomial operations. So we have this first x plus 2 and we have x plus 3. So Python can never do this one, and it's actually left to a coder, to a data scientist to do more operations for this one, and this is going to be the next thing that we're going to have.
Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn and upskill for free.